Everyone pictures the Big Bang as a massive explosion, a cosmic fireball erupting from a single point, flinging galaxies outward like shrapnel into empty space. You could point at the night sky and imagine tracing back to where it all started, like finding the center of a blast radius. That mental image is completely wrong. Here's the problem with that picture. It assumes space already existed for the explosion to happen in, and that's where the entire misconception starts. The Big Bang didn't happen in space. It is space. Every point in the universe came from the Big Bang, and understanding that difference changes how you see everything around you. Let's start with what an explosion actually is. An explosion releases energy from a central point. A bomb goes off and debris flies outward through the air. A supernova detonates and stellar material races through space. The key detail here is that explosions happen in something. They require existing space for material to move through. There's a center point where the explosion originated, and everything spreads out from there into the surrounding area. Hollywood reinforces this misconception constantly. Films like Independence Day and The Core show cosmic events as massive explosions with clear center points and debris fields spreading outward. That visual language is so ingrained that it's become the default way people picture the Big Bang. They imagine a tiny point of concentrated energy that suddenly detonated, sending matter racing outward into a pre-existing void. It's a natural image because that's how every explosion we've ever witnessed works. The Big Bang wasn't debris flying through space. Space itself has been stretching since the beginning. This isn't just semantics. The difference between matter moving through space and space itself expanding is fundamental physics. If the Big Bang was an explosion, you should be able to point to a spot in the sky and say that's where it happened. You should be able to identify a center point with galaxies rushing away from it in all directions. So where is it? The answer is stranger than you think. There is no center of the universe. There's no edge. There's no surrounding space that the universe is expanding into. This means you're not looking back at where it happened. You're standing in it. Right now, everywhere is the center. Drop a comment if your brain just broke a little. I want to know which part hit you hardest. The no center concept or the everywhere simultaneously idea. Think about the debris analogy. In an actual explosion, chunks of material move through existing space. They have trajectories. They're traveling from point A to point B. But in the Big Bang, galaxies aren't racing through space away from some cosmic ground zero. Space between the galaxies is growing. The galaxies are being carried along as space itself stretches. This leads to the most common follow-up question people ask. If the Big Bang wasn't an explosion at a specific location, then where did it happen? The answer sounds strange at first, but it's accurate. It happened everywhere simultaneously. Every point in space came from the Big Bang. The region of space you're sitting in right now was part of the Big Bang. The space between distant galaxies was part of the Big Bang. There was no single location because location itself was being created. NASA's Wilkinson Microwave Anisotropy Probe research confirms this. The cosmic microwave background radiation we detect isn't coming from a direction. It's everywhere. It pervades the entire universe uniformly because the Big Bang happened at every point in space. You can't point to where the Big Bang occurred because you're already there. We're all already there. The explosion model fails because it treats space like a container. It imagines the universe as a box that stuff happened inside of. But space isn't a container. Space is part of what's expanding. The universe doesn't have a location. It is all locations. This means the explosion model isn't just wrong, it's fundamentally backwards. So what's the right way to think about it? So let's break down exactly why that mental image fails. The Big Bang was the expansion of space itself. Not an explosion into space, but space stretching and carrying everything with it. This is the core concept that changes everything. Now, here's where it gets weird. I'm going to describe something that sounds completely unrelated to the universe. But once you see how it works, you'll never picture the Big Bang the same way again. Ready? Imagine a loaf of raisin bread rising in an oven. As the dough expands, the raisins move apart from each other. But the raisins aren't flying through the dough. They're not racing away from some central raisin. The dough between them is growing, and that expansion carries the raisins along with it. Every raisin sees all the other raisins moving away.
Fluid, and the cosmic fluid looks the same in every direction. There is no preferred orientation. It's said to be isotropic. Now what you'll notice is that the cosmic fluid is spreading out. It doesn't matter where you look, you see the same thing.
There's no center to the expansion. No raisin is special. And that's exactly what's happening with galaxies in our universe, including ours. Galaxies aren't racing through space away from an explosion point. Space between the galaxies is growing. The fabric of space-time itself is stretching, and galaxies are embedded in that fabric. The farther apart two galaxies are, the more space exists between them, and the faster that space expands. This is why distant galaxies appear to be moving away from us faster than nearby ones.
যদি আমরা কল্পনা করি যে এই বেলুনের উপরের বিন্দুগুলো গ্যালাক্সিগুলোকে এবং বেলুনের পৃষ্ঠটি মহাবিশ্বের স্থান কাল জালিকা বা স্পেস টাইম ফ্যাব্রিককে প্রতিনিধিত্ব করে, তাহলে বেলুনটি প্রসারিত হওয়ার সাথে সাথে সমস্ত বিন্দুগুলো একে অপরের থেকে দূরে সরে যায়। সবগুলোই একে অপরের থেকে দূরে সরে যাচ্ছে, এবং আপনি যে বিন্দুর উপরেই দাঁড়িয়ে থাকুন না কেন, অন্য সবগুলোকে আপনার থেকে দূরে সরে যেতে দেখা যাবে।
But this raises an even stranger question. If distant galaxies are moving away faster, how fast can they actually move? Here's something that sounds impossible. Some galaxies are so far away that the space between us and them is expanding faster than the speed of light. So distant galaxies are moving away from us faster than light. Einstein said nothing can move faster than light. So which rule is breaking? Here's the mindbender. Neither. And here's why. Think about Interstellar's wormhole concept. The film shows a shortcut through space that lets you travel vast distances without breaking the speed limit. You're not moving faster than light through space. You're bending space itself. Real cosmic expansion works on a similar principle, except instead of bending space, space is stretching. So in the movie, they cheat by bending space. In reality, space doesn't need to cheat. It just stretches. And there's no speed limit on that. General relativity allows for space to stretch at any rate. This expansion has been happening since the earliest moments. According to NASA research, the universe we observe today was once compressed to just a few millimeters across roughly 13.7 billion years ago. It wasn't compressed at a location. It was compressed everywhere. Every point in our observable universe was part of that hot, dense state. The evidence for this expansion model is overwhelming. The cosmic microwave background radiation is the remnant heat from when the universe was extremely hot and dense.
The CMB isn't just one wavelength, it's a spectrum of wavelengths, and the spectrum is exactly what would be emitted by an object with a temperature of 2.7 degrees Kelvin, or minus 450 degrees below 0 Fahrenheit. Actually, the temperature is very precisely known. It is 2.725.
We detect this radiation uniformly in every direction because it came from everywhere. Galaxy recession rates match the predictions of an expanding universe. The abundances of light elements like hydrogen, helium, and lithium match what we'd expect from nuclear fusion reactions in the early hot universe. The shape of space itself doesn't change this picture. Space could be flat, spherical, or saddle-shaped. All three geometries work with the expansion model. Recent measurements indicate space is very nearly flat, which is the easiest shape for us to picture. But regardless of shape, the expansion works the same way. There's no center, no edge, no privileged location. This is why the language matters. Calling it an explosion creates the wrong mental model. It suggests a blast from a point, debris flying outward, empty space surrounding the event. None of that describes what happened. The Big Bang was the simultaneous appearance of space everywhere in the universe. That region of space within our observable horizon was indeed extremely small in the past. But if all of space is infinite now, it was born infinite. If it's finite and closed, it was born with zero volume and expanded from there. Either way, there's no center of expansion, no point from which the universe is expanding away. In the raisin bread analogy, all points on the surface move apart from each other identically. No raisin is at the center because there is no center. So here's what this all means. So here's the question this should raise in your mind. If the Big Bang happened everywhere simultaneously and you're standing in it right now, what does that mean for the future of the universe? Most people think they know the answer. They picture the universe slowly cooling, fading into darkness, the heat death. But now that you understand how space actually works, you might see why that prediction could be completely wrong. Next week, we're exploring that exact question. We're debunking the heat death misconception and showing you what the universe is actually heading toward. If you want answers, subscribe. And if this video changed how you think about the Big Bang, hit like. It helps us reach people who are tired of misinformation.